All right, an arithmetic sequence was what we talked about last time. That's when each successive term, to get each successive term, you add a number, so their differences are the same, right? They have a common difference. In the case of geometric sequences, the ratio between successive terms is a constant, and we call it the common ratio R, all right? So that means if I take two terms, and if I divide them, I get the same. We take two terms. So take a look here. This is A2 and this is A1. And if I do A2 over A1, this is the common ratio R. So A2 over A1 is 9 over negative 6, which is what? Negative 3 over 2, right? So that's the common ratio R. That means to get each successive term, we're not adding or subtracting the same number, we're multiplying by the same number, okay? So, and then it says, find the next three terms of each geometric sequence. So we have negative 6, 9, negative 13.5. So what would we do here? We would multiply by negative 3 over 2. And then you would multiply by negative 3 over 2. And then you would multiply by negative 3 over 2 in order to get the next successive terms. Okay? So in the first case, what would be the next number? So 13.5 times 3 over 2. We would get positive 20.25 times 3 over 2. We would get negative 30.38. And then 45.6. There is a common, if it's a geometric sequence, there is always going to be a common ratio. If it's a geometric sequence. That's what a geometric sequence is. Okay? All right. So now, let's do one here. Let's find the common ratio for this one. So this is A2 and that's A1. So R is going to be negative 81n plus 243 over 243n minus 729. Okay? And you notice from the top here, I can factor out a negative 81. And that gives me n minus 3. From the bottom, I can actually factor out a 243. And that gives me n minus 3. Oh my, look at that. They cancel. And it turns out 81 over 243 is 1/3. So this just gives me negative 1/3. Okay? Yes? Now, we need to find the next three terms. So we're going to take the very last one, multiply by what? Negative 1/3 times 27n minus 81. Well, that gives me negative 9n plus 27. Then I do it again. Multiply that by 1/3 this time. And I get 3n minus 9. And I do it again. Negative n plus 3. So these are the next three terms. Okay? Now, suppose I start with, I have a sequence. The first number is 5. Okay? this is A1. Okay, that's the first number. Now suppose also that R is equal to 2. Okay? Is there any way we could find, what would you do to get A2? Multiply by 2, right? So it would be 5 times 2. Okay? Now, how would we get the next one? We get this and multiply by 2. How would we get the next one? Multiply by another 2. How would we get the next one? Multiply another one. Okay? Another way to write that, there you go. So another way to get that would be, this is a 5, right? Here, in the second term, I have 5 times 2 to the 1, because it's all about exponents. 5 times 2 to the 2. 5 times 2 to the 3. 5 times 2 to the 4. Okay? Well then, the first one was what then? 5 times 2 to the what? 0. So now, right? So now, look at this. How many 2's are we multiplying with each step? N minus 1. If n is 5, I'm multiplying 4 r's. If n is 10, I'm multiplying by 9 r's. So the formula then, which you guys just came up with all on your own, is this. To get an, so suppose now I wanted to get A57, the 57th term. I would have to get the first one, 5, times 2 to the power of, how many for the 57th term? 56. Multiply it by 2, 56 times. So let's write an explicit formula for this. Okay? Okay, this is the formula. This is how we get the explicit formula. Okay, so now, what's A1 here? -1, and A2 is 2. What I want is R, so that's -2. So the explicit formula, okay, is AN is A1 R to the power of n minus 1. So AN is A1 times R, I just found that to be -2, to the power of n minus 1. -2. And you know what? I can't do much more with this, so that's it. This is where I stop. That's the explicit formula. So now if I wanted to get the 547th term, all I do is plug in n equals 547. Now, we're not done with this one yet. Now we need to find the recursive. That means if I am at the 60th term, how would I find the very next term? What would I do? Well, would I have to do that? So look, if I'm here, if I'm at the first term, what would I do to get the second term? Multiply by what? Which is -2. And then if I'm here, I multiply by -2. Now, if I'm on the 60th term, to get the 61st term, I just have to multiply by -2. Okay? So for the recursive formula, we say, okay, first you have to tell me what A1 is, and then each term is the term that comes right before it times R. Okay? So if I'm on the second term, the third one is just second term times 2. The 80th one is just the 79th times 2. The 100th one is 99th times 2. So specifically, A1 is -1. AN is AN minus 1 times -2, because that's what R is here. And then we just write it more elegantly. So AN is -2A n minus 1. Okay? All right, so here it says to find the 11th term. So I want A11. And this is the geometric sequence. Now, the formula for AN is A1 times R n minus 1. So I need to find R. How would I find R? Right, 115.9 over -122 is R. So it's -0.95. Okay, and that's cool. We can get decimals. So A11 is A1, which was how much? -122 times -0.95 to the power of n minus 1, how much? 10. This is just a plug-in. You just plug it into the calculator. So A11 is -73.05. Is that right? Okay. So we talked about arithmetic means. Now we have geometric means, and basically it's the same thing. Geometric means are the terms between two non-consecutive terms in a geometric sequence. Okay? So if I randomly select the third term, and then I randomly select the seventh term, all the numbers in between are the geometric means. They either tell you if it's arithmetic or geometric, or you could just tell, because you see, like, if I subtract consecutive numbers, am I getting the same number? Or if I divide consecutive numbers, am I getting the same number? Okay. Yeah. Let's finish this. So okay, so first, whoops, where is it here? So first I need to find R for this one. Okay. So look, let's see how this is going to look. 264, and it says to write a sequence that has 3 geometric means. 1, 2, 3, and then I have this. So how many total numbers are there? 5, so n equals 5. And A1 is 264. So now, AN is A1, R to the minus n minus 1, 1.03125 is the first number, AN, times R to the power of 4. Okay, now I divide by 264. Is equal to R to the 4, right? What would I do now? Take the 4th root, or raise it to the power of 1 over 4. Same thing. So either way, R is 0.25. Imagine that. So now at each step, I'm going to multiply by 0.25. So that means divide by 4. So here I get 66. Divide by 4, I get 16.5. Divide by 4, I get 4.125. And sure enough, when you divide by 4, you get that 1.03 blah, blah, blah. Okay, cool, yes? Okay. Okay, so geometric series. Geometric series is when we add, so it's the indicated sum of the terms, okay? I'm gonna leave the derivation to later. The two formulas to find the sum are these two. And again, we use each one based on like what we have. So if you look at formula 1, for example, all you need for it is A1 and R. If you look at formula 2, it calls for A1, R, and AN. So if you don't have AN, you can't possibly use formula 2, right? Okay. So here it says find the sum of the first 11 terms. So I need S11 for this geometric series. Okay, so this tells me that n equals 11. The number of numbers I'm adding is 11. R is negative 6 over 4, which is negative 1.5. Once in my life, I'm going to go with decimal over fraction. Okay, so let's use formula 1. Because I don't know what AN is. So it's A1, 1 minus R to the N, over 1 minus R. The derivations are actually like really, really cool. And I'm hoping we'll have some time for them later. So S11 is equal to 4, 1 minus R over 1 minus negative 1.5. Okay, so plugging it in. And then the rest is just putting it in your calculator. And I get that S11 is 140. Okay. Okay. So here it says, find the sum of the first n terms. Okay. So let's see what I'm given. I'm given A1, AN, and R. Is there a formula that I could use with these three? Formula 2, right? Sn is A1 minus ANR over 1 minus R. So this is negative 4 plus. So it's minus, it's going to be a plus 65,536 times 2 over 1 minus 2. So this is negative 131,068. All right. So I actually, do I know how many numbers are in this list? Do I know what n is? No. And that's fine, but I still was able to find the formula for it. I mean, the sum of it. Okay. Now, what about this one? Okay, so here, let's see if we could find our information from here. All right, what is this number? If it's something to the power of n minus 1, what value is that? That's r, right? Because it's always r to the power of minus 1. So r is minus 2. Now, can we figure out what n is? So we start from n equals 3 and we go to n equals 8. N is it just 8 minus 3? Plus 1. Because you have to count the 3 as well, right? So it's 3, 4, 5, 6, 7, 8. Because if you start at 3 and end at 8, how many did you go? 8 minus 3. If you start at 3 and went to 8. Okay, yeah. So n is equal to 6. Now, can we figure out what A1 is? Huh? No, because it starts at, yeah. So, okay, so A1 is not necessarily the first term. It's the first term when you've started counting. So if you're starting from 3, 4, 5, 6, 7, 8, like this first one is actually A1. You know what I mean? So A1, that's the first term. So it's Yeah, yeah. So it's -2 to the 3 minus 1. So this is -8. Okay, so what's the formula that we're going to use here? The first one. Okay, so A1 is -8. And then I have 1 minus r to the power of n, so -2 to the power of 6, right? All over 1 minus 6. Huh? Oh, it's 1 minus r. Did I write 1 minus n? Oh, whoops. It's 1 minus r. So what was r? -2. Okay? So this will be 168. Okay? Yeah. Okay. So there is a, okay, so so these were sum of a finite geometric sequence, right? This was all sum of a finite geometric sequence, one that ends, a finite geometric series. What if it's an infinite geometric series? Okay, well, so here you can't do it all the time. So if r is greater than 1, okay, so for example, if r is like 5, okay, then you're multiplying the numbers by 5 each time. So when you have an infinite number of numbers, your number is going to reach infinity, and the sum of that will be infinity, right? So this is going to increase without limit. Therefore, like we have no way of adding it, okay? Now, if, I'll go over examples of this in a minute. If r is less than 1, okay, so suppose r is like 1/3, okay, then r to the n approaches 0. Okay, so let's talk about this for a minute. So suppose r, the absolute value of r, okay, suppose r is equal to, let's say, 5, okay? Now, if I do r to the n, that'll be 5 to the n, and then you can tell, like, if it's an infinite series, it's just going to be like 5 to the infinity, and that's just crazy, okay? Now, what if r is 1/3? And what if I take 1/3 and I raise it to the power of n? Okay? So suppose like it's 1/3 to the power of 10. Okay? What would that be like? That's 1 to the 10 over 3 to the 10, right? Is that a big number or a small number? That's a very small number. Now, what if n was not 10? What if n was 100? It's even smaller. What if n is infinity then? This value will reach to 0. Okay? So if r is less than 1, then r to the n approaches 0. Okay? That means we can only have the sum of an infinite series if r is less than 1. So you have to look at if it's an infinite series. This is only for infinite series. If it's an infinite geometric series, if r is greater than 1, you can't take the sum. But if r is less than 1, then this is the formula. Okay? So if possible, find the sum of each geometric series. So let's see what r is here. R is 18 over 24. So the absolute value of r is the absolute value of, what's 18 over 24? 0.75. Now, is that less than 1? That's less than 1. So we're good to go. Okay? So I say S is A1 over 1 minus R, 24 over 1 minus 0.75, 96. Because it's 0.75 each time, right? So if you start with like, I don't know, if you start with like 1, then the next one is 0.75, then it's 3/4 of that, then it's 3/4 of that, then it's 3/4. So the numbers get less, and you can find the sum of it. Okay? All right, so what about this one? What's R? 0.66 over 0.33, which is what? 2. Absolute value of R, which is 2, is greater than 1. So that's not cool. That's not possible. Okay. What about this one? How much is R? R is 0.65, which is good because R is less than 1. Okay. So let's figure out what the first term is. A1, that's 3.65 to the power of 2 minus 1. That's the first term. So A1 is 1.95. Okay, so Sn is A1 over 1 minus R, 1 minus 0.65. So Sn is 39 over 7. Okay, oh, just on time. All right, so this homework will be due next time.